We will first start with the overview and description of the apparatus. First of all, the turbine wheel is located inside a steel casing located on the left side of the apparatus. It can be observed through a window located on the side of the steel casing. The discharge reservoir contains the water which will be pumped into the system and eventually used to turn the turbine. The discharge through the system will be measured using the V-notch weir located on the right side of this reservoir. A glass window next to a graduated scale is located at the front side of the reservoir and allows for the direct measurement of discharge. A Pironi brake is used in order to create a brake torque on the turbine's rotating shaft. The Pironi brake is comprised of an adjustment screw that is used to apply the torque and a graduated scale with a mercury column to measure the brake force applied on the moment arm connected to the rotating shaft. Also note that there is a reflective white sticker located on the rotating disc of the turbine's shaft. This will allow the tachometer to measure the rotating speed of the rotating shaft. Two valves can be found on the apparatus. The lower valve is used to control the available discharge for the apparatus, while the upper valve, called the needle valve, is used to adjust the pressure head responsible for rotating the turbine. The dial gauge indicating the pressure head is located in front of the steel casing between the two adjustment valves. During this experiment, you will only be required to adjust the pressure head, therefore using the upper valve only. It is important that the adjustment of the discharge valve does not change during the experiment. Now, we will make sure that the apparatus is set up properly before commencing the experiment. First of all, there should be water flowing through the system indicated by the V-notch weir. Also, a water jet inside the steel casing should be rotating the turbine's wheel. Afterwards, make sure that the Pironi brake is not applying any torque to the turbine's shaft by turning its adjustment screw counterclockwise. The mercury column of the Pironi brake device should indicate 0 on the graduated scale next to it. We will now be going into the procedures of this experiment. The first step is to set the needle valve at the first pressure head indicated in the lab manual. Please note that the pressure head applied will have to be corrected using the calibration chart provided in the lab manual. For the same pressure head, measure the discharge over the V-notch weir. The discharge measurement is obtained directly by reading the discharge corresponding to the water level on the calibrated scale located on the front of the discharge reservoir. Afterwards, using the Pironi brake adjustment screw, apply the first braking force as indicated by your lab manual, while making sure that the turbine's shaft is always rotating. Record the brake force by reading the height of the mercury column on the graduated scale next to it. Do not exceed the brake force indicated in your lab manual. For this brake force measurement, determine the rotational speed of the shaft using the tachometer in the following manner. First, point the beam of light projected from the tachometer onto the reflective white sticker which is located on the disc connected to the rotating shaft. Although this might be hard to see, try to focus the entire projection onto the sticker. Also try to remain your hand still, as any movement will not result in a stable reading on the tachometer. Now, repeat this step for all the remaining brake forces as required in your lab manual. After increasing the brake force to the maximum value, release the brake force by turning the Pironi brake adjustment screw clockwise, such that the mercury column height is now 0 on the graduated scale. Now, you may vary the pressure head for the remaining runs as indicated by your lab manual, using the method described in the previous step. Once all the required measurements for the last pressure condition are performed, remove the force on the Pironi brake. Then turn the upper valve counterclockwise such that the needle valve is corresponding to the first pressure head reading. This concludes the procedures for this experiment. The following procedures are for the startup of the apparatus by the teaching assistant. First, make sure that the discharge valve of the apparatus is closed by checking that it does not turn in the clockwise direction. After this, make sure that the needle valve is fully open by turning it counterclockwise. Make sure there is enough water in the apparatus reservoir. Otherwise, add water using the water hose in the vicinity if necessary. Roughly, the water level in the lower section of the reservoir should be at the height of the bottom of the upper section of the reservoir as shown. Now, turn on the pump by pressing the green button on the power panel located on the left side of the apparatus, followed by opening the discharge valve fully by turning it counterclockwise. Apply the maximum brake force as indicated in the lab manual and adjust the discharge valve such that the shaft is rotating at a reasonable speed, as well as achieving the lowest pressure head indicated in the lab manual. Once the discharge valve is adjusted, it is important that it remains unused during the entire experiment. Release the brake force by turning the prony brake adjustment screw counterclockwise, such that the mercury column height is now 0 on the graduated scale. The apparatus is now ready for use by the students. The following procedures are for the shutdown of the apparatus by the teaching assistant. First, make sure that there is no force applied on the prony brake by unscrewing the adjustment screw such that the mercury column height is now 0 on the graduated scale. Afterwards, make sure that the needle valve is fully open by turning it counterclockwise. Then, close the discharge valve slowly by turning it clockwise. Finally, turn off the apparatus pump by pressing the red button on the power panel located on the left side of the apparatus. This concludes the procedures for shutting down the apparatus.